you look at these histograms, what is similar about all of these? What is similar about all of these histograms? Guys, let's put our phones away.
Do they not have a toe?
Say it again.
Do they not have a toe?
Don't have a what?
A toe. Like
Tail. Okay, yes, they don't have a tail, they're not skewed. And because they are not skewed, what does that lead you to think that they are? Symmetric. Yes, they are all symmetric. Even though they look vastly different. This is symmetric because if you find the middle, it looks the same on the right and the left. Here we find the middle, same on the left and right. Here in the middle, same on the left and right. So, first thing we're going to say is all three of these histograms are symmetric. Okay? We're going to look at this. All three histograms are symmetric. Now, I also just remember that at the top of your paper, it talks about standard deviation. And let's talk about standard deviation. Hey, who's got the munchies? Did you bring enough to share? No? What kind of Doritos are they? What? Barbecue Doritos? Okay. Okay. I'm not as interested anymore. All right. I know. Everybody's like, all right. Standard deviation. What can you tell me about standard deviation? Got 2 words. Yeah. What else? Hey, up here. I know, you're trying to trade for somewhere. Talk to me about standard deviation. Somehow I don't think we're talking about standard deviation. Oh, were you? What were you saying? Houdini, tell her over here. She's talking some stuff. I don't know. Nobody has any idea about standard deviation. Hey, guys, a little too loud. Standard deviation. Standard deviation is going to be a measure. So let's put this at the top. A measure of the, how do I want to say? It's how variable, a measure of the variability of the data. Yes, standard deviation is a measure of the variability of the data. Okay? If you have a small standard deviation, excuse me, it's my turn right now, okay? If you have a small standard deviation, that means that your data is clustered closely together. Clustered closely together. Okay? Whereas if you have a large standard deviation, the data is spread out. Jeez, now we got Cheez-Its. What, we just need to have a snack day or something? All right, so small standard deviation, your data is close together. Large standard deviation, spread out. Is that the same as the range? Is standard deviation the same as the range? It kind of sounds like it. What is the range? Jacoby's like,
Turn around.
what is the range? Oh mon Dieu, come on people. Range. Maximum minus the minimum. That is your range. So yes, It can be part of it. The range kind of tells you how large we're talking about, but it doesn't talk about all the scores in the middle. Here, I have a range. I have a highest score of 11 and a lowest score of 1. What's the range here? No. Close, but no. You actually need to subtract. So 11 minus 1 would give you 10. So the range here is 10. What is the range here? High of 11, low of 1. 10. Do you think these are going to have the same standard deviation? No. Which one looks more variable? Tyler. Which one looks more variable in its standard deviation?
The bottom one?
I'm looking. I think so because, why do you think the bottom one?
Because they are clustered up in the same height.
Okay. These are kind of in 2 clusters. These are kind of 2 clusters too, but this one has a 0.